Welcome back to Cosmic Compass, where we journey together through the wonders and mysteries of the universe. Every world, no matter how small, carries a story worth telling. Today, we set our sights on Phobos, the tiny moon of Mars, with a giant problem. Its orbit is dragging it closer and closer to destruction, and one day, this little world will meet a dramatic end. But how and could we ever stop it? Let's find out. Phobos may only be 22 kilometers across, but this tiny moon of Mars hides one of the most dramatic fates in the solar system. While it looks insignificant compared to the giant worlds and their massive moons, Phobos is locked into a slow-motion tragedy that will one day end with its destruction. Today, let's uncover its strange orbit, the forces tearing it apart, and whether we could ever save this fragile little world. At first glance, Phobos doesn't look like much an irregular rock scarred and battered, but appearances can be deceiving. Phobos is actually the closest orbiting moon in the entire solar system. It circles Mars at a distance of just 6,000 kilometers above the surface, far closer than our own moon, which sits 60 times farther away from Earth. Because of this closeness, Phobos orbits Mars in only about 7.5 hours. That means it moves faster than Mars itself rotates. If you were standing on the Martian surface near the equator, you'd see Phobos rise in the west and set in the east, only to rise again within the same day. In fact, you would watch it cross the sky twice every Martian day. But here's the catch. If you travelled too far north or south above 70 degrees latitude, you'd never see Phobos at all. The planet's curvature would hide it from view. Now, such an intimate orbit comes at a cost. The closer a moon is to its planet, the stronger the tidal forces it experiences. For Phobos, those forces are immense compared to its fragile structure. Scientists estimate that Phobos only has around 50 million years left before it will be torn apart entirely. Evidence of this doom can already be seen in the form of long grooves and cracks across its surface, what scientists call stretch marks. These fractures reveal that Phobos isn't a solid monolith, but more like a loose pile of rubble held together weakly by gravity. And gravity is slowly losing the battle. Every year, Phobos spirals inward by about 2 centimeters, pulled relentlessly closer to Mars. One day, the tidal stress will overcome its fragile body, breaking it into pieces. When that happens, most of the debris will fall to Mars, creating massive impacts. But some fragments may stay aloft, circling the planet for a few million years. Imagine that Mars, with its own temporary ring system born from the death of its moon. But let's pause for a moment and ask, could we stop this from happening? Could we save Phobos from its doomed fate? After all, it's only 22 kilometers wide. Surely we could nudge it with a rocket and give it a safer orbit, right? Well, not so fast. To change the orbit of any object in space, we need to change its momentum. For Phobos, whose mass is roughly 10^16 kilograms, even a tiny increase in velocity requires staggering amounts of energy. Let's say we wanted to boost its orbital speed by just 1 millimeter per second. To do that, we'd need to eject about 500 million kilograms of propellant at a velocity of 20 kilometers per second. The energy required, on the order of 10 or 16 joules, roughly the power of a nuclear explosion just to achieve the tiniest nudge. Now, maybe we don't need to fully move Phobos outward. Maybe all we need is to cancel out its slow orbital decay of 2 centimeters per year. That sounds easier, but the numbers still add up quickly. To offset that decay, we would need to fire propellant continuously about 0.03 kilograms every second year after year. Over the course of a single year, that becomes 1 million kilograms of fuel. And remember, this is just to hold Phobos, where it is not to rescue it with a safer orbit. The scale of the task is enormous, far beyond anything humanity has ever attempted. So what does this tell us? It reminds us that even the smallest bodies in space are far from insignificant. Phobos may be tiny by cosmic standards, but it is still about 2,000 times heavier than all the coal humanity mines in a single year. It's a sobering thought, the idea that a moon so small compared to others can still be utterly beyond our ability to control. For now, Phobos is destined to meet its end, whether in a fiery crash onto Mars or as a fleeting ring encircling the red planet. As we watch the clock tick down on cosmic scales, at least Phobos becomes a powerful symbol. It shows us the fragile balance of forces that shape worlds, and it reminds us how small our reach remains in the grand theatre of the universe. And that's the tale of Phobos, the doomed moon of Mars. It may be small, but its fate speaks volumes about the forces that shape our solar system. In the end, gravity always wins. What do you think? Should humanity ever try to save a world like Phobos, or should we simply watch its story unfold as nature intended? If you enjoyed this journey, don't forget to subscribe to Cosmic Compass, leave a like, and share this video with fellow explorers of the cosmos. Until next time, let's keep looking up, because the universe always has more stories to tell.